All right, so today we're going to be looking at figuring out the chemical formulas for ionic compounds. Essentially, when ionic bonding occurs, how do we know the chemical formula? So the key thing with ionic bonding would be those first three letters. We're working with ions here. We're working with these atoms, these elements, after they've given up or taken electrons to kind of have stable electron shells. What we're going to learn though is when the electrons are happy, once they've done that, the atoms themselves aren't happy because they don't want to have a charge. They essentially want to be neutral. And so what these atoms will do to kind of reach that kind of overall neutral charge is they're going to combine with things of opposite charges in such numbers to cancel them out. Getting straight to this, let's say that I have an ionic compound with lithium and nitrogen. The first thing I'm going to ask is what charge are these things going to form? As I magically scroll somehow. Okay. So lithium. Lithium is right here. It's in column 1. It has one outer shell electron. So then my question is going to be, is it closer to 0 or closer to 8? 1 is most definitely closer to 0. So lithium will get rid of that one outer shell electron. So now what I'll have, one more positive proton than has negative electrons. So lithium forms a charge of positive 1. All right, so let's do the same thing with my nitrogens over here. Nitrogen, it's over here in column 1, 2, 3, 4, 5. All right, it's in column 5. So that means 5 outer shell electrons, closer to 0, closer to 8. 5 is closer to 8. In fact, for nitrogen's 5 outer shell electrons to get to 8, it will need to take 3 negative electrons in itself. It will now have 3 more negative electrons than positive protons. Nitrogen forms a charge of negative 3. So let me get rid of the and here. All right, we have room to work now. All right. Now to figure out how many of each of these I need to get to an overall charge of 0, essentially where the number of these equals the number of this. Okay, this is just a little bit of algebra. 1 times what would get me to 3? Well, 1 times 3. So if I had to indicate that 3, so charges go up top, number of atoms will go on the bottom. Okay, so I'll put that 3 down there. I don't even need that positive 1 there. All right, so then my whole goal here between these two, essentially what I'm looking for between those two charges, I'm looking for the least common multiple. The least common multiple of 1 and 3 is 3. So 1 times 3 gets me to 3. With nitrogen, I only need the one nitrogen. So now I have, my lithiums, I have 3 of them. Each lithium has a charge of -1. Sorry, positive 1. To it, I need to add the charge of my one nitrogen. In that case, just -3. There's 1 of them. Okay. So now I have positive 3 plus -3. That, if I remember right, should equal 0, right? So for an ionic compound involving lithium and nitrogen, Li3N, that's kind of my base formula unit. I'm going to have tons of these things, but they're going to be in a 3-to-1 ratio is really what we're going to see. There's an easier way, like going through this algebra stuff, that's fine, that's cool. It's very useful to see, oh, okay, these things form together in such numbers that the overall charge is 0. But let's say that I'm working with aluminum and oxygen. All right, aluminum right here, column 3, charge of positive 3. 3 outer shell electrons, gets rid of them, 3 more protons than electrons, positive 3. Oxygen is in column 6. It is 2 away from 8, so oxygen will take 2 electrons to get up there, charge of -2. Rather than going through all of this kind of algebra type stuff, if I quit writing on where I'm trying to work, all right, what I can do is what I call the crisscross method. What I'm going to do is I'm going to take this number, I'm just going to put it right there. I'm going to take this number, I'm going to put that right there. So the chemical formula for this will be Al2O3. All right, so now you're going to ask, oh, where'd that sign go? Essentially, when we crisscross, signs get left behind. Everything becomes positive when you crisscross. Because it's a cool dance move. Everybody loves to do it. It's positive. All right. But, so this crisscross method, let's make sure this works. So I have two aluminums. Each aluminum has a charge of positive 3. Altogether, we know 2 times positive 3, positive 6, right? Oxygens, I have 3 oxygens. We said each oxygen had a charge of minus 2. 3 times negative 2 should get me negative 6. Positive 6 plus a negative 6, 0. Crisscross method works for all of these. Let's go with calcium and sulfur. Calcium forms a charge of positive 2. Sulfur forms a charge of positive 2. Crisscross, I end up with Ca2S2. All right. This, okay, thank you for that. So in this case, this is actually not correct. Essentially, if we could simplify this down, we should. You know, algebraically, this can be simplified. Like 2 and 2, no. We would have 1 and 1. Essentially, positive 2 plus a negative 2 is 0. I mean, looking at this one, we would have 2 times positive 2 plus 2 times negative 2. You know, that's positive 4. That's negative 4. We still get 0, but we can simplify it. That becomes especially true like when we start working with things like that can have a charge of positive 4, but we're going to worry about that later. So today's kind of video was just all about crisscross method. I'm either at this point in class or after you see this video, I'll probably jump up on the table and do this dance, the crisscross dance. I hope to see you doing it when you take a quiz. I know it's helped some people in the past. Otherwise, ionic bonding, really easy. First step, write the charges. Second step, crisscross. I'm going to go through one more real quick. Let's go through magnesium and fluorine. Magnesium, column 2, charge of positive 2. Fluorine, column 7, 1 away from 8, negative 1. Crisscross it. These things, when they form an ionic compound, Mg1, F2. You don't have to put the 1, it's kind of implied. Crisscross method never fails. Good luck.